Good evening, everyone. Bonsoir à tous et à toutes, and welcome to tonight's presentation of OTF Connect, titled From Counting to Multiplication, a Developmental Perspective on Primary Number Sense, with Matthew Aldridge. We have a very nice group tonight with mostly experienced users. We've planned an interactive session, so it should be a lot of fun. I would like to thank you all for taking the time away from your families to meet us over TF Connect, to share your ideas and your experience. Comme d'habitude, je voudrais profiter de l'occasion pour souhaiter la bienvenue à nos collègues franco-ontariens. Nos sessions sont principalement en anglais, mais si vous désirez obtenir des informations en français, surtout n'hésitez pas à me contacter par la suite. We are definitely thrilled to have each and every one of you with us tonight. It's also our absolute pleasure to welcome Matthew Aldridge. Matthew is a resource teacher of mathematics in the alternative program of the Peel District School Board. As I mentioned last time when I moderated for Matthew just a few weeks ago, he sent me a one-line resume for his introduction, and I must admit that I have particular admiration for anyone able to summarize their entire curriculum vitae in just a few words. So in his own words, this is how Matthew likes to introduce himself, I guess. So I'm opening virtual quotation marks here. Matthew is a father, educator, TEDx speaker, thinker, writer, and tweeter. And as I said last time, when I received this email, he added, "That's enough of a bio, I think," followed by a smiley. Close quotation marks. So how cool is that? I think it's pretty cool. And I think that in a world that often tends to be non-realistic to the extreme, Matthew's resume is certainly refreshing. So yeah, it's 7:32. Matthew, so at this time, if you want, feel free to click on your talk button to turn your microphone on, and then go ahead with your presentation.
Yes, thanks Michelle, and thanks very much for coming. And it's true, I mostly like to let my Twitter feed stand in for my curriculum vitae because it shows my interests and my thoughts and just where I'm at. So if you tweet tonight, you can tag myself and at OTF_PD. And the Twitter as the back channel only adds to the conversation, I find. So if you are on Twitter, please do. Some background for tonight, why it's happening. So in a lot of the work that I've done for the last 3 years as a resource teacher of all mathematics for the second largest school board in Ontario, we found this huge demand for what we call, well, a developmental perspective on mathematics, period. Okay, and then attached to that, what we call either trajectories, continua, or landscapes for learning. Regardless of what you call them, it's very true that the 2005 curriculum, speaking of elementary, is not so much enough anymore. It's older. It does have a nice learning progression for what it is, but lots more research has happened since then, and it really, really helps us to think more developmentally. So what I'm trying to say is if I were a kindergarten teacher, we're going to talk about counting in the first half tonight. And so if I know how kids and humans generally learn how to count, then I'll be able to assess them more effectively and I'll be able to help them. My observations and conversations about their developmental learning and about counting will allow me to help them. And moving up through adding and subtracting, same thing. If I know what to look for, okay? And so thinking developmentally helps us with that, very, very much so. Yeah, so that was a little bit of a background for why tonight is happening. Also, I would strongly encourage you to attach this one to Kyle Pierce's session, and he tweets as Mathletes Pierce, which you may know. And he called it the progression of multiplication. So he and I in OTF talked when we had similar ideas. So what I'm actually doing is taking us up to the point where kids are about ready to develop their understanding of multiplication. So I'm going to move us from counting through to adding and subtracting, and get us right where we need to be, and then he's going to move us through multiplying. Okay, and so I'd strongly encourage you to join that. I personally was in a session on multiplication at OAME 2 years ago, and participants were asked to come up with multiplication means, and we came up with 24 different meanings, so unique ones, different ones, and that's just an example of how complex these landscapes can be. So strongly encourage that you take Kyle Pierce's next, I guess a week from tomorrow. My mission statement for myself personally, what if every kid said math is surprise and wonder and playing with numbers? I guess I came to this, the link will be coming up shortly for the TEDx talk, and I did call it Math Classrooms Should Be Places of Surprise and Wonder, because I just felt like that as soon as I started developing this perspective for myself, my students started to like math a whole lot more. So if I made the math classroom a thinking space and a space to wonder about interesting ideas in mathematics, they liked it more. And then what's more, I was often surprised by the quality of their thinking. And lately, something I've been thinking a lot about is play in math classrooms. So playful mathematics, mathematics pedagogy, as I once heard Kathy Bruce talk about, that we can play more, and that play is not just for Z class, for music class, playing music, it can be playing with numbers and playing with mathematical ideas. So this is a bit of an improvisation, but it's something I'm working on. A little bit of mathemagic to start us off, and we're going to use the chat box for it. I'm going to get you to think of any number, so just any number at all. Yeah, it really doesn't matter. Let's just make it a positive integer, though. Let's just make it any whole number. And then I would like it for you to multiply. I'd like for you to multiply your number by 2. And then after that, sorry, I'm going to start that part again. I'd like you to double your number. That's what I meant to say. So I'm just going to drop this in the box because I'm just playing with this little bit of mathemagic. Think of a number, double it. Okay, that's where we're at. We've done 2 things. So we've thought of a number and taken 1 action. Now take what you have and now multiply that number by 5. And that's in the chat box. And that's it. Think of a number, double it, multiply it by 5. If you just don't mind, if you can just drop your number in the chat box, I'm going to do something with it. Okay, I see 20. All right, we've got a few coming in. Okay, so if I did this right, actually, Chaco, can you check yours? Can you just check? So whatever your initial number is, double it, and then multiply by 5. How do I know that? So I'm going to say Eniko or Aniko, your number was 2, and Monique, your number was 3, and Esther, your number was 5, and Deanna, your number was 5, and Alana, your number was 5. We're checking this one. And then Ariel, your number was 8. Kathy G, your number was 6. Melora, your number should have been 12. And Amy F, your number was 9. Jennifer H, your number was 6. And Anne, your number was 5. And Robin, your number was 2. Jenna C, maybe check the 8. Check that you doubled and then multiplied by 5. Just let me know. Okay, so Kristen H, your number. Oh, those were the intermediate numbers. Sorry. Let me just check. So Kristen H, I'm sure your number is 28. Heather L, your number is 18. Candace, your number is 23. Cindy Z, your number is 13. Elizabeth P, your number is 37. And Amber, your number is 11. Now, if I got any of those wrong, I'm a bad mathematician. But I'm trying this for the first time, and I was going to use it. I thought it'd be fun to use with some parents. Okay, so if you have any ideas for how the number trick works, you can put it in the box. But basically, I can look at your number, I can look at your output and know your original number because I just chopped the 0 off. And I just chopped the 0 off because of this. So think of a number, and let's just call it n. So double it. So we now have 2n. Multiply by 5. We now have 10 times n. And then 10 times a number, I know I can just drop the 0 because of place value. So 120 goes back to 12 because I know all that's actually happened is you multiplied 12 by 10. So I'll just give that one as an example. 12 times 2 times 5 equals 120. I could just drop the 0. So what's disguised is that we did 10 times the number. Yeah, so we disguised some algebra basically. And I know we're about to move on to the primary landscape, but perhaps you can think of one that you can fool 7-year-olds and you'll think they're a math magician. And if I got it wrong, it's not my fault. It's the trick's fault. Or blame algebra, how's that? But it should have worked. Anyway, so a little bit of play with numbers. And yeah, there's lots of those tricks out there though. Lots of tricks. Most of them rely on a little trickery with algebraic manipulation. What's the biggest number you know? So my point here was, yes, once I was playing with my sons and I said, well, what's a big number? And they're like, when they're 3, they'll say, oh, 10, right? And then when they're a little older, they might say 100. And then when you got a little older, somehow they came to know the number or non-number infinity. But we were just playing with adding zeros and adding ones, just playing with markers and paper. So you can just see kids, they're even backwards, some of the numbers. But before they can get to thinking about really big numbers, they have to think about small numbers. And indeed, from birth, they have to have some kind of conception of number at all. So how does that even happen? So it reliably does in humans, right? We know this. And when we hear those kids counting 1, 2, 3, they're just trying it out, thinking of 2-year-olds and 3-year-olds. Actually, even 1-year-olds when they first hear the names for the numbers. So sometimes they might learn that sequence in a very rote way, and they say, well, what's actually happening? So, and I wanted to say again, I've experienced this. I have a 5-year-old turning 5 tomorrow, and a 6-year-old. So I've seen this firsthand recently. So before we have to count big numbers, before we get to thinking about infinity, we start at 1. Okay. So another introductory exercise, and this is where for Michel's workflow, so either his email, or I'm going to get you a Google Drive link just right now, that we can use for anything tonight. There'll be 2 spots. Okay. So Google Slides link is going in. So basically what you can do with that Google Slides link is you can just treat it like your slideshow. If you want to paste something on a page, paste it. Okay. And option 2, email Michel. So if you drop your work in that Google slide deck, what I'm going to do is I'm going to upload it into this presentation. Okay, because what we realized last time was I had participants doing a little bit of work outside of Blackboard. But of course, it's the recording that exists after tonight. So anything that we make can go into this presentation. So this is called a dot image. And Jo Boaler is very, very famous. She just released another TED Talk from Stanford and originally from the UK. And some of us got to see her at OAME Leadership in Brampton last November. And she did this exact dot image. And she had teachers say, what do you see? And so she sort of led a bit of a math congress at the back of the room. And she was drawing it out as participants described it. And so there was actually fully 24 different ways of seeing it. So the first couple of people can try drawing it on the screen. But what do you see and how do you see it? Okay. And so if you can either describe in words in the chat box, or if you draw the 7 dots on paper, I want to know initially what you saw. Actually, I just realized one thing that would be a little bit better, if we can just hold on. What I'm going to do is I'm going to pull these, sorry to whoever did this, I'm going to just pull these off for a sec. Just to start again. So I'm just going to pull it off. We can play with it a little bit after, just so it's clear. Okay, take what you saw here. Now, what I'm going to do is hold that image in your mind. So I'm going to go away from it for a minute, and I'll put it back in a minute. And so for those who are drawing, you can finish showing us what you saw. So now picture it in your head, and either draw it on paper or describe in the chat box what you saw. And an example of being descriptive would be how you saw them arranged. If you saw any shapes around, like if you mentally drew any shapes that helped you to count. And I think typically with kids, you probably want to show the image a little less long than I did, but so, and then one other thing you can do is if you just draw the 7 dots on the page and just email them to Michelle or drop them in the Google Drive link. Okay, so we have some coming in: right diamond with sideways roof, a hexagon with a central dot. Yes, I see 3 on left and double dot on right, and 1 in the middle. A butterfly, excellent. And your words are very descriptive. And you may try, if you do these activities, dot images, you may try, you know, either way. You could give kids a template of it, or just flash it and have them draw it, or just have them describe it. It's like 2 diagonally, 3 diagonally, 2 diagonally is very descriptive. 2 eyes, the 1 center dot is the nose, and the rest are the smile. Yeah, some people are looking at the Google Doc. If there's any, if you have a quick way to drop a photograph in there to illustrate what you saw, please feel free. I'm loving the description in the box. Dice 5 and 2 on the ends is also really interesting. Now I'm going to put it back up. So those who are drawing on the screen, feel free to go ahead and show us what you saw. I just realized, well, maybe I shouldn't show the image for so long because it takes some of the mental machinery or the visualizing away. Okay, but now we're all really picturing it. And I don't recall when I first encountered this what I originally saw. Right now I'm kind of seeing almost 3 triangles, which I've never actually thought of before. I see 2 triangles on top and 1 in the bottom, kind of like a base. And I almost want to take these sticks and show it. A flower. I'd be really interested to know about that one. Okay, let me do my 3 triangles. Okay, now that we're really going, if you want to come over and draw on top of it. And I'm just going to mark that with my initials because you know what? I never saw that before, and I'm proud of it. And I'd like you to know, and so I'm assuming we have mostly I guess, kindergarten to grade 3 teachers, that if you gave it to kids, what would they see? I mean, adults saw it 24 ways, and I bet tonight we have 28 people. We may well have 28 different ways. I don't know the answer to Aniko's question about the mobile app because I've never used it. And I don't know if Michelle can help as well if you've used it. And so for Monique C, you said you didn't see a thing. What about, did you perceive 7? Oh yeah, only 7 dots. Oh, okay, so that's a unique one itself. So seeing them as just separate dots on their own. And I now see things that other people have mentioned. Now, I do think that that is one of the really strong benefits of visualizing, that we can see things that other people see. It's quite true that when we look at problems, so let's say we have a math congress and we look at kids' different solutions, there's often those real serious aha moments because they'll say, well, I never ever thought of that before. And that's part of when I was referring to math classrooms should be places of surprise, that you'll be surprised. So somebody saw it differently than you. I'd actually love to see if someone wants to take a different color other than the yellow I used and put an excuse me, put another one on the screen. 2 trapezoids. Oh yeah. So it's really, and on that note, we saw a hexagon as well was one of them. And then so the flower. Oh yeah. So crown with a huge triangle. I want to see, and that's why I say, feel free to sketch on it. If we wanted to, we could drop some more blanks of this in again, or it's easy to find on the internet. But actually, I found the verbal imagery really worked for me. So the one we just got was 4 directions of 2, 3, 2, starting at the top, and then starting at the bottom, starting at the top left-hand side, starting at the bottom right-hand side. So it's, yes, so when you look at it that way, it's very, very symmetrical. Okay. So as we get sort of ready to wrap this one up, I'd like you to think about. I'm not going to say how you saw, because there may be, you originally probably perceived 7, and then the shape of it took shape somehow, or it didn't, or you just still saw the dots as separate. And then with the help of other people's mental imagery, probably, oh, you were trying to think, do I see that? Do I see the flower? Do I see the trapezoids or the triangles or whatever? But it would be just wonderful to see what a whole class of kids would see. And I did see a teacher doing this with grade 1s, and they did just great. And a huge part of it is building their verbal reasoning skills from a young age. So visualizing and verbal reasoning. So taking the mental imagery and getting it out. Okay. But we're going to relate this to very strongly to counting. And we're going to start at the very, very beginning of when kids learn to count. I'm just going to check my notes. So make sure I mention everything that I wanted to. And I think we're good so far. Great. So, and if you try that tomorrow, be sure to tweet me some things that kids say or what they do. Okay, learning to count itself. So from a very early age, perhaps even by 4 months, I didn't cite this, but it is from, oh goodness, I summarized a couple things. Okay, unfortunately I didn't put the citation on here. But this is more like a general summary, and it's, I think most researchers and psychologists would generally agree. So, and then babies can tell the difference between 2 and 3 objects, so maybe by 4 months. And if you've had a baby in your life, you could probably remember when that started to happen. By 1 year, looking at different sizes of sets, and I think that the concepts of more and less, more cookies and less cookies. And if you've ever seen toddlers fight over more and less cookies, then you know that that's very serious business. By age 2, perhaps they know some number words. And I think like the counting sequence is so cultural, and if they've been exposed to any TV at all, and assuming if you like stuff like TVO or Treehouse, just if you were to turn that on for even 10 minutes, I bet you'd hear 1, 2, 3, 4, 5. And I bet if you're of a certain age, that might call to mind Sesame Street. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, that thing. Anyway, that was maybe 1970s Sesame Street. And then, but knows that they're important. Yeah, but sometimes it's kind of a rote recitation of the counting sequence. And between 3 and 4, knows that the last number counted answers the question, how many are there? And in the counting landscape, they call that cardinality. trusting the count as well, but just knowing that they're not just tags, but they can tag them. So if I'm counting 10 objects, like 10 toys or 10 pieces of Lego, when I reach 10, I know that there's 10 objects there. And between 3 and 6 roughly, so the sense of addition is combining, which is pretty easy to do. You'll see a picture of, I found this really fun teddy bear manipulative from Spectrum, and it is right here. There's actually literally just a bag of small, medium, and large different colored teddy bears. Anyway, with my boys, we were just working on some fun counting. But I said, well, 1, 2, and many. And I tweeted to Number Cognition, which is Daniel Ansari, and he actually works on early number sense at the University of Western Ontario. But so literally, some cultures just have 1, 2, and many. So I was wondering about the rest of the counting words, how they do that. And he says it's just cultural somehow. Okay, but so one very interesting sort of digression is when we say, so I went to Japan, and so when we say like first, second, third, fourth, and fifth, they have different counting words so for different types of objects. So when I was first looking at the language, like long, skinny objects, like bottles, have certain counting words. That's completely true. So you'd have to know different types of counting words in order to count in Japanese. So in that sense, the job is tougher for young Japanese children. But they actually have a system where the team numbers, which are quite hard for kids, and some of the kindergarten and grade 1 teachers are maybe nodding their heads. But so 1 to 10, okay, sure, you learn it. But what's 11? What's 12? Well, in Japan, and actually a bunch of other languages, it'll go, you get to 10, and then it's 10-1, which is actually Juichi. So Ju-ni, 10-2, and then 10-3, and so on. So that part of it is actually easier. So just a digression about counting in different cultures. Okay, so subitizing. So a fundamental skill in developing students' understanding of numbers. So I feel like the word subitizing is everywhere these days. So about 2 years ago, I feel like everyone around me started to say it, which is a really, really good thing. And it's because we were just starting to understand that this process of instantly seeing, which just kind of happens, is so crucial to number development. And definitely checking my notes here because I want to cover it. So you're going to have a link to Douglas Clement's article. He's written a lot about early number sense. His article on subitizing, not too long. I strongly recommend it. Clement's trajectories for early number sense, which includes counting, they're about to come in. And hot and fresh, hot off the press, as they say. So there's some ministry sessions, webinars, Adobe sessions on early number sense. Yesterday they finished part 1 and 2 of 4. Part 1 and 2 that are already posted are definitely relevant to tonight's session. And I would encourage you to check out everything that's there for the renewed math strategy. The ministry has gotten a lot better at documenting their work, and I can vouch for the early number sense one. The quick images, this thing that we're about to do, I got the idea from there. Okay, so my notes for subitizing. I noted, and Dr. Ansari told me because I asked, in psychology, up to 4 objects, seeing at once that there's up to 4 in your head. Okay. But in perceptual subitizing, we can think in terms of maybe up to 20. So which are these? So perceptual subitizing, so no mathematical processes are really happening. Okay, there was some dice images on the title screen, and we're about to see some. You don't have to do anything, okay, in part because they're so familiar and cultural. But if it's 4 objects, even 5, maybe even a few more, there's not much you have to do. Conceptual subitizing, I think there was some hints of that in the dots that we did. So a group of 2, a group of 3, and a group of 2. That's an example of that. Seeing parts of the whole, seeing patterns, or maybe units of units. So a unit of 2, a unit of 3. Okay, something interesting about this mechanism of subitizing. Some studies apparently show that there is no counting without subitizing first. Okay, and I would like to propose, maybe some of you were in my spatial reasoning a couple weeks ago, spatial reasoning is also everywhere, and seeing numbers spatially and seeing mathematics spatially is also something where we don't maybe really understand why it's connected to mathematics, but we know that it actually is. So I was wondering if subitizing is connected to this spatial sense somehow. That's just a bit of a conjecture, though. And from Clement's article, just to be clear, so I don't like it when people give vocabulary words and don't define them. According to Mr. Clement, direct perceptual apprehension of the numerosity of a group. So instantly seeing how many are in a group, in other words. And they say some animals, they've proven with studies, can subitize somewhat. I don't know. I guess that would be with food again, maybe. Up to 4 pieces of food that they want to eat, and they choose the one that has more. I'm not actually sure, but those would be interesting studies. Okay. So one slide aside, this is an extra link. So just a 12-second YouTube video that I just dropped in. It was my son. We were just playing with those teddy bears. It's just a funny little 12-second video. Next, yes, and so this will be another activity piece, and the chat box is absolutely perfect for this activity. And so my questions are, well, first of all, just keep what do you see in the back of your head. But my question's more of a teacher one this time, and more of a subitizing one. So which one is the easiest to deal with? Rank them from easiest to hardest. And this activity comes from some Enrich stuff on subitizing in early number sense. So rank them from easiest to hardest. So if I thought this was the order of easiest to hardest, I might write A, B, C, D, E in the chat box. But perhaps it could be C, B, A, D, E, whatever it is. I may say just go with your instincts. I'm not really feeling like there's one overall right answer. And you can go to the Enrich where they have this activity after and see if it matches your thinking. I'd say again, like as long as you can back up your own reasoning, you know, and we'll take the next maybe like 4 minutes to do that. But do drop something in the chat box. So let's put the easiest, start at easiest, and go through and make a list through to hardest, in your opinion. And I was in a webinar last night, and we were asked, and I know that you're afraid of being wrong, because I was last night. And then I'm like, no, I should just put my ideas in the chat box. But in this case, as I'm saying, as long as you can back up your reasoning, it's about perception, so you can't really be wrong. So please drop something in the chat box as something comes to you. All right, so we have some answers coming in. Well, it might be interesting if we get a bunch of data here. We might get sort of a general kind of consensus on which ones are easy. I mean, there's a lot of A's in the first position. Actually, there's a few that are A, E, B, C, D, or A, E, B, D, C. And yeah, and so C was another pick for easiest. And I would definitely, so that we need the reasoning on, that's from Esther. And then, so people who thought A was the easiest and thought C was the easiest, I think those are the only 2 choices.
What you could do that is quite fun is that, you know where we had the little green check mark and the red X? I've not put a multiple choice,
Oh, yeah,
so it's A, B, C, D, E. So I guess
right,
what people could do is maybe we could say which one is the most difficult, and people could pick up the most difficult, and then we could see which one
right,
comes first.
Because I think that varies a little more. Okay, so most difficult seems to vary a little more than most easy. So if you can use the multiple choice to pick the most difficult, that might give us a different data set. Oh, I love it. Data. And so C's come through. So
you guys click on the little A, and then you can select your option A, B, C, D, E, and then I will post them online once you're done.
Very interesting. That gives us a different perspective on this data set. And so for Deb 5 number, Deb S. That says, anyway, so for Deb number 2, when you say subitizing addition of addition facts, which one was that? This is definitely what I would want from kids, though, is I've reassured them that our reasoning is what matters. We value everyone's reasoning. Feel free to get your reasoning in there. Oh, there's the data. So we thought C, D, and E were the hardest.
Yeah, here you see it. It's C and
then
D.
or none. None were hard.
Yeah.
Interesting. It's
C and then D. Yeah.
Okay, so now I'm seeing from the data, so some of us didn't have trouble with any of them. I just wonder if we were working with, I'm going to say, let's say we're working with a 5-year-old, and we're not sure if all their counting is fully in place, as we'll talk about in the second half, and we're using these as quick images to check, and we're seeing what they see. And if they have less of a lifetime experience and confidence with subitizing, I'd say even that A, it's the most symmetrical. And yes, it's the dice. And yes, my 4-year-old would recognize it on the dice. But can we think like kids and come up with a reason? So we see, for those who felt C was difficult, it's because they're more difficult to see when they're in the linear order. Maybe you can't count as quickly as when they're grouped. Yeah, so maybe it forces you to go one by one. That is interesting reasoning. I can see right there. Okay, and I'm going to offer, I feel like it's understood, but I'm just going to say for A, familiar 5 dice arrangement. Easy, and in part because of the cultural nature of it. But you could push me for more reasoning, and I'd say 2, 1, 2, two groups of 2 and 1, 1, 1. Okay, so for B, I feel like these 2 groups aren't hard to see. For C, I might be inclined to agree that it's a little harder because it might force you to count one by one. This one looks like a blob, which might make it harder. Closer inspection might show this 3 in here. And this one, regular arrangement of 4 and 1, fairly regular if you see it like that. So let's see, the only ones that were picked for hardest though were C or D. So maybe the blobby one and the linear one. And so yeah, so squares or triangles are easier to see. That's good. And so we had some comments about B and E chunking and how it helps. That's good. I'm inspired by the thinking of this group. I think it's great. And I would love to see, tweet me some pictures and things that kids have said about even this activity. You could make up any dot cards and do this to work on their subitizing. But I'd love to hear what they say. Okay, and I was in one of these dot number talks with my colleague Farah, who was an instructional coach, and she sat down at the guided the guided reading table, and she was using it for guided math. And it was the kids who were struggling somewhat, and one of the kids had a real breakthrough. And he was really, really keen to say what he was thinking. And so the teacher, all she knew was he wasn't usually that engaged. But given a chance to explain his reasoning, he really, really wanted to do that. And the small group probably helped as well. So giving kids a chance to explain their reasoning is so key. So C, group of 3 plus curve 2. So if you see grouping there, it makes it easier. Yeah, and I think we're starting to see a perceptual pattern, and one that could actually really, really lead us down the road to eventually multiplying. And that's grouping, so seeing things as groups. So C is easier to see, and kids still count 1 by 1, so they may get it faster. Right, so if they are just at that 1-to-1 counting stage, and they're not instantly seeing, it'll be faster for them to count in a straighter line. Okay, I'm checking my notes here. I think, did our Enrich Math link go up? I'm just going to look back. The Enrich link, you can see what their reasoning was, and it's actually where the activity came from. Alright, the link isn't there. Let's see. Is that the main link? No. So before we did this activity, the link went up, and it's an article called "Number Sense Series: Developing Early Number Sense," and they show this, and they say a lot of what we just said. And there's an example of a few games. Yeah, there it is again. Or no, that was from 8:02. So at 8:02, and I just copied it, so I'm going to drop it in again. And you can see their reasoning. Okay, this part should be fun, and I'm doing it again. Okay, this is going to be a series of quick images. So quick images are one of the big instructional strategies for Subitizing. I'm going to go through them quickly. And I wanted to say, these were my images, but if you get into the ministry sessions, they had an awesome, like absolutely awesome set of quick images that they did with us, just like I'm about to do. So that can augment your experience. But for us, we're going to see a series of quick images. We're going to talk about it, and then you're going to create some of your own. So I'm just going to say how many, because Subitize is instantly seeing how many. And I'll just give about 1 second for each slide. And then we'll go back through, so don't worry, we'll come back. Okay. How many? How many? Oh, I mean, people responding, which is great. If you can instantly Subitize, you can instantly, almost as instantly type. I don't know if I should be going a little quicker for adult audience, but oh, easy for us if we've ever bought eggs. That one's harder, and it's going to be up screen. Oh, okay. We'll come back to that one. The card game called Set, which we discovered. Some cards from that. Okay, good. So now we're going to go back through. Okay, and I'm enjoying the. I'll give a bit of commentary on this one, but I'll give a bit of commentary on each, but feel free to type anything in each box. Wow, we have some people who saw 18 instantly. We have some powerful, powerful Subitizers. Okay, the familiar 5 on the dice. Yeah, 2, 1, and 2, an X, but you know, it's so cultural. It's just a familiar arrangement of 5. Same with the 4. However, perceptually speaking, if we think of it as 2 groups of 2, that's going to help kids for sure. And that's also on the road to adding and subtracting, and on the road to eventually multiplying. The 6 and 2, I suppose they're dice, so it's still familiar. Yeah. Well, I would say the 6 is double 3. So do we see 3, 3, and 2? And it's so familiar. It's hard for me to get new perspective on dice. You know that. I realized that from working with my own children. But this one, doubles. So my son's in grade 1, and there was some point last fall when he did a lot of work on the doubles. And so he can say 6 plus 6 is 12, and if this comes up in rolling two dice, he can say that, which is great. So it's about, I think, the familiar arrangement. So 3, 3, 3, and 3, 6 and 6. Again, there's lots of perception that can happen. So perceptual subitizing. But yeah, the equal groups and the doubles, so key. Related concepts would be eventually skip counting, as we'll see. Yeah. And then so the 10 frame as a tool, these are the spongy ones. I think they come from Spectrum. I just happen to have some. Very, very nice tool. You can see at the side they can be attached to other 10 frames. But so 10 being such an important anchor, especially for place value. But this time I put them, 2, 1, and 1. But it still wasn't hard to see 4. Although, you might just have that kid that says 6 because of the green. Okay, that's the 10 frame. Eggs, I don't know why eggs are actually sold in a dozen. I think I looked that up once and forgot. To us, a dozen's a dozen. It's a familiar unit. But kids have no unit. They have no egg unit without knowing about eggs or without you talking about it with them. And that actually makes egg carton math somewhat interesting. Because it's based on 12, you could do interesting fractions later on, like maybe in grade 2 and 3. But to us, this is 6 and 6. But then you're like, okay, again, what do you see? 2, 2, 2, 2, 2, 2. Maybe they see groups of 2. Rows, columns. Okay, but a slightly more unfamiliar 12. This one, I wanted to throw you off with 4 different dice, but some people still said, actually did 6, 10, 14, 16. I think someone still got this right away. Assuming the 4 is up, which I'm pretty sure it is. It's 2, 4, 4, and 6. So again, it just disrupts the familiar. I don't know if I would expect, say, grade 1s to subitize this quickly. It's a little beyond, especially with the numeral, the symbol, and then the dots mixed, but I wanted to try it. Oh, this one is a very interesting game set, which always has 3s. It's such a cool card game that we bought. We ordered from Amazon and tried. It really is an amazing math game about sets and attributes. But 3, 3, 3, 3, 3, and 3. Again, it's forgetting about the shapes. It's an array of 3 times 6, or 18. Right, so this is the one a lot of people got really, really quickly because groups of 3. So it was quick work with either, skip counting is the deep basis, but multiplying. One note here that's so important. I spend a lot of time working with high school teachers, and so a lot of them are very, very good at math, but they've forgotten how compressed their knowledge base is, and that means a lot of things they frankly they've forgotten learning, right? So they would automatically go 3 times 6 is 18, and it's, well, how do you know that? I just know. And yes, at this point they do just know because they've used that fact enough. But what's deeper than that? What did they do as a kid to know that and to understand that? And what is 3 times 6 anyway? Well, here's one arrangement. So giving kids a bunch of experiences with it, breaking it down, pulling it apart, looking at this as repetitive adding, obviously first. So skip counting, 3, 6, 9, 12, 15, and 18 could be something that you do first. This one, I'm actually not sure how grade 1s would do. You might try all the same shape, the groups of 3. Okay. And that was the last one for the ones that I picked. So I want to see how creative you can get. I want to say, if you're in the mindset of Googling, that there is, once we pay attention to it, it's like patterns and numbers of things just everywhere in the world. So you're going to say like an arrangement of 5 roof beams, for example, and you take a photograph of it. Or I'm looking at those IKEA Kallax shelves right now. They're in 2x4 arrays, and we have some on their side and some standing up, and they're full of toys. But each one has 8. So that would be something else I could take a photograph of. Okay, and the instructions, this activity we need a decent chunk of time, like at least 5 minutes, maybe a little longer. And so check your camera roll. Okay, if there's something you can get right away, either by emailing Michelle or for me, using the Google Slides link, and dropping the pictures in there, I can upload them to this presentation. And that helps because you or anyone else who comes in later can use that image in their class. They can be inspired by it. Okay, so either the email option or the Google Slide option will work. And what we're going to do is we're going to monitor, and whatever comes in, we're going to upload it into this presentation.
Matt, can you post the Google Slide option again? Yeah. Can you post the link?
Oh yeah, I'll do that. Sorry, just for 1 sec. Things you can look for: anchors of 5 and 10, images that require grouping, unitizing doubles. We've talked a lot about that, and even things that are in the natural world. Okay, I'll find my Google link again. Oh, here it is. Yeah, so we have no images in it, and I'll actually try and Google a few and get creative as well, just to get that slide deck going. And if you are Googling an image and you right-click and you copy and paste into the Google Slides, it's just that easy. So if you get on a roll, dump a bunch in. If you're on your camera roll, I don't know your phone, but whatever your workflow is, if you can just, if it's an iPhone and you quickly hit that email button and you have Michelle's email, then that's easy. Okay, so I'm just going to turn the mic off just for a few minutes and see if I can find a few interesting images myself.
Hi, Gina. So this is Michel. Matt has turned off his microphone as we are doing the exercise. So basically right now we are just collecting images and posting them. And I just got a new one from Cindy. I'm going to share it in a minute. But Matt is going to be back soon. Lots of great stuff here, and Matt is going to comment them in a few seconds. I think we have, how many do we have here? 1, 2, 3, 4, 5, 6, 7, 8. We got 8, I think. 1, 2, 3, 4, 5, 6, 7, 8, 9. We got 9 images, so thanks so much for sending all these in. And then and another one, an interesting one.
Yeah, amazing.
Yeah, thanks. And I just got another one from Kathy. I'm going to post it as well.
Yeah. I know I did miss a couple. I just wanted to make sure I get to the end of my stuff tonight. You can keep that Google Drive link. I think typically the main thing you see is dot plates, and so you may know teachers who have the pie plates, like the paper ones, and they take the bingo dabbers and they make their dot plates. That's cool, but these are really cool. So let me just go back through them. And the first one was the roses. So I might see groups of 3. Oh, it's the familiar dozen as well. Less familiar to kids. Puzzle pieces I put in, actually that one's a little hard to see. First it looks like 9. I wondered, like, scattered puzzle pieces, would that work? You could try it. Classroom those puzzles. You know, another cool manipulative, it's like my teddy bears. Another one's coming there. This one, hard to subitize, but I see a central arrangement of 5, 8, 10, 12, 14, 16. I had to use my skip counting for that one. That one's super cool, in different colors. Yes, the orange slices. 8. That one's interesting, because I felt like I should know how many slices there are, but it took a while to get 8. It's actually kind of like a pizza as well, which is usually sliced into 8. This, the first page of the slides had some really cool ones, like 3, 4, and 3 owls. The Santa Snowman is the familiar dice, and there's the familiar dice as well, and another 5 and another 5. So there's a set that are 5s. There's the starfish, which is either 2 starfish or 10 arms. And I do like that the starfish are different sizes. That gets out a different point as well. 5 is 5 regardless. The V of birds, I really like. Actually, my brain isn't telling me how many there are without looking closely. And next, chocolate fondue or something. No, it's coffee cups. 4 cups. Oh, they're in a neat stack and 4 saucers. Okay, that's cool. The next set from the Google slides, I think the familiar 2x4 Lego brick, or 8. There's so much math in Lego. And if you can justify spending it on your classroom or for your own children, which I spend a whole lot of money on, it's because it's the mathiest thing there is. You just say to your principal, well, spatial reasoning is hot now. Spatial reasoning leads to math success. Let's buy lots of Lego for the classroom. But in all seriousness, block play predicts later mathematical ability. But like, think of all the math, and we're going to just get on to adding and subtracting, but then even the multiplying. Yeah, and so, yeah, Lego is one of the mathiest things that there is. These are, iPads in a classroom. How many? And then the probably wine barrels arranged. I definitely easily see the 5 on the left. And then the Rec and Rec, or 10 frame. What do we see? Do we see 7, 8 on the left? Must be 12 on the right. Great for adding to make combinations to 20. I quite like the hands. That's actually, the 5 anchor is important. So we anchor 5 before we anchor 10. And so we have 5 fingers. So most people have 5 fingers rather. Almost everyone. So 5, 10, 15, 20. Also skip counting. And we have 5s and 10s on our body. I like the spider as well because everyone knows there's 8 legs. So that's like a unit of 8, or 4 on one side or 4 on the other, or 2, 4, 6, 8. Anyway, the unit of spider legs. And 2 spiders would be 16. Oh, an array of paintings. Yes, I was going to do that in my living room. I don't have this many paintings. That's good. A nice array. And then this is my original. Oh, yeah. This is the next slide. I just got excited there. So thank you for all those. Hopefully, if you need any of those, my suggestion would be get to know your screen capture tool, whatever it is. Okay, so if you look this Google, or if you look up this presentation on a phone or iPad, you can use screen capture and crop. On my PC, I have the the screen snips tool stuck to the side of the screen because I use it so much. But you could snip them, you could put it into Seesaw or Google Drive or whatever you use, or just show them on the screen, or you could set up your own little quick deck set to go. Like you could set the timings for every 4 seconds even in PowerPoint, and do this with kids. And as we wrap up the counting section, you could learn so much just from watching a kid count the set of objects, okay? And it's true. My kids counted the bag of teddy bears. There was actually 100. I learned so much, okay? My 4-year-old counted carefully by ones, and he tagged each object carefully. I had to encourage him to move the ones he'd already counted out of the way, like his workspace. And then my 6-year-old skip counted by 2s, which again he learned in school and he's worked with a 100 chart, but he was looking for something a little faster because there was more. And these are things that you can notice, and these are not small things. You can learn a lot from watching a kid count. Oh, here's one. I've got 2, 4, 6, 8, 10. Yeah, neat. I'm looking at the buttons, but 2 and 2 wheels as well. A sense of 10, much needed for place value. Much, much, much needed. Right, so in cultures that didn't have place value before we use the Arabic numerals that we do, like in ancient China, for example, they just left an empty space. But that wasn't really as easy to work with. So we need place value to work. That is, we need each successive column to the left to be 10 times as big as the one to the right. So we need our unit of ones, our unit of tens and hundreds, and so on. Or we won't be able to read our numbers, and that's true. But how do we do that? By developing a sense of 10. And Enrich calls it tenness, needed for place value. The 10 frames, these are these spongy ones. They're a good tool. The Reckon-Recs, which we just saw pictured, Reckon-Recs or bead racks, depending on what they're called. You can have kids make their own. You just need some beads and string. Also a key tool. And just noting here is that we make the anchor of 5 before we make 10. Okay, and you can even think of data management, tallying, 1, 2, 3, 4, cross is 5. We have 5 fingers. Okay, 5's an anchor too along the way, so don't discount that. Humble 100 Square as a thinking tool. I told, like, some of the humblest thinking tools are the best. Like a number line, or just drawing a rectangle for area, or for multiplying. Like the 100 Square is an awesome thinking tool, and you know you can do so much with it. You can teach kids skip counting, for one thing. So my son did that as well for groups of 2, groups of 3. Probably they're going to look at counting by 5s and 10s. Probably first. And anyone can correct me if I'm wrong, but probably 2s, 5s, and 10s. And so look at how easy it is to skip count by 10s if you look down the column. Okay, so Humble 100 Square is a thinking tool. And the link that's about to come in is to the Mathy's 100 Square tool, which is an interactive one. You can flip multiples over, flip numbers over, and you could use that with kids. I mean, paper's good, but in a lot of my work, I heavily promote the OAME and Ministry Mathy's tools because they're getting better all the time. So so when that link goes in, I recommend exploring the tools at mathys.ca. It's an interactive 100 Square that you can use. We won't dwell because we need to get a little farther. This one, so our number system can be revealed. So I've just given one where I've got the prime numbers in yellow. And that's for later grades, right? Except though, if you cross out all the neat skip counting numbers, these are the numbers you're going to be left with. And that's interesting. I just really like prime numbers. The prime numbers are revealed. Okay, this is again difficult brain work, but based on everything so far, don't be shy about this, please, but put some ideas for what you would think would be in a developmental continuum. And landscape or trajectory are two other words that are often used, probably roughly synonymously. That goes from counting in early number sense right up to adding and subtracting. So you might think of it, if you're using the chat box, you may think of whatever you think comes first, type it in there. Based on what you've seen tonight or what you know. And then things that you think come along the way. I feel like we've mentioned a lot of them tonight. But we'll just get some ideas, and then I'll show an example of what teachers thought, and then I'll show some of what researchers have thought. But I do like to hear what we think first. To me, that's good constructivism. But I won't let you flounder, but we'll just get our ideas out, and then we'll see what some experts have thought. So counting by benchmarks is one that we think would be early on. Anything else you want to toss in? And I guess actually a good point, you don't need to think of this as totally linear, because a lot of the counting concepts will develop concurrently as well. And sometimes it just happens. So subitizing we think would be near the beginning. Anchoring to 5 and 10, so also mentioned. Yeah, cardinality and trusting the count, conservation and anchors. So conservation, knowing that a group of 7 is always a group of 7. Grouping of items and joining groups to add. Wow, we know a lot about this stuff. This is great. Hierarchical inclusion is definitely another one. So if I look at 7, I know that there's a 2 and a 3 and a 2 and 7. And we could see that with objects, or that there's a 6 and a 1. They're contained within 7. And counting on as an adding strategy. Outstanding. Wow, you could do this yourself, and this is amazing to see. One-to-one correspondence would probably come quite early on, and as we talked about. And if it didn't, that'd be something you can really specifically help kids with, say in helping them tag with their fingers. Yeah, we've got a lot of the big stuff. So part, whole, yeah, absolutely. So if I have 12 objects, 8 and 4 as parts of that whole. And I might add to that number combinations or number bonds you sometimes hear. So making 10, and then we can maybe look at making 20. And I believe the curriculum for grade 1 has number facts 220. Friendly numbers, that's a good one. Fact families might be another way of saying what I just said. Super, and I'm just realizing it's 8:42, so I'll just keep going. So what some teachers thought in my friend John's class. Actually, specifically, he did a number talks workshop, and it was amazing. But so you can see what teachers thought. It's by no means exhaustive, but I just picked this picture because it was teachers doing the work, and it's difficult work, but it's work that we can do. Okay, and to a lot of our teachers, Kathy Fosno, the landscapes of learning were the key things. And so here she is. She's a researcher that's done a lot of this work. The link that's coming up is to a document of the learning exchange of this adding and subtracting landscape. But so what she's got is, so the big ideas are in oval, and the models are in triangles, and then the landmark strategies are in rectangles. And so you can see subitizing is at the very bottom in a rectangle. But as I was reading her book today, and it's not meant to be linear in any way, so a kid could be all over the place. The teacher who has used this one has highlighted 3. I'm not sure why, but I think that's an example of maybe how you can use it for assessment. So look at all the things that need to be in place before kids can even add. Rather, this is the landscape through, from number sense through adding and subtracting. So look at all that's involved. Now, and I even think of the journey of this webinar, and so in the past, maybe when I was in grade 1, the teacher might not have known to look for all these things. So it would have been either math you can add or math you can't add. But now it would be Matthew can add, but he needs to work on this, or Matthew can add, and he's good with all this, or Matthew can't add, and I know he's still struggling with making 10, or making his number bonds, or even back to subitizing. Now think of how much more powerful this is, seeing mathematics developmentally. Alex Lawson's great book, What to Look For. This is actually a 3-minute video. You're going to get the link. You can feel free to go away for 3 minutes, but like we're definitely running out of time, so you could save it for later. It just happens to be, if you get the book, you get access to all the videos, and they happen to have one sample on YouTube. What makes me excited about this book is that well, this is actually quite random, but I am a PL teacher and my kids are in PL, and the research for this book was done at their school, which is Brookmead Public School. And I know for a few people who were there, this might even have been their students. So Alex Lawson is a Canadian researcher, is what I am saying, Canadian researcher. And so she has her own landscapes for counting, adding, subtracting, and then the book has multiplying and dividing. But it is a K-3 book, and it's changed a lot of our teachers. I didn't put a sample of her landscapes in because of copyright, but I strongly recommend buying this book from Pearson. And I think what you would see compared to the Fosno is a much simplified landscape. And teachers that I've seen of using it are literally, they're checking on 3 or 4 kids per class. They're looking for certain strategies or big ideas, which she uses. Anyway, you can see the kid in the video working on a adding and subtracting problem. This one, I think I'll just leave for now. It was 15 plus 16 as a number talk. And if you're not familiar with number talks, so Sherry Parrish is the book reference. But you can find them all over YouTube. But basically in the video for 15 plus 16, we'll see what strategies are kids using. And so it's intended to be a mental one. And I was going to ask you to put in the chat box how you got the answer to 15 plus 16. We're just running out of time a little bit. An example of that could be 15 plus 15 plus 1. And this is the perfect time to point out is that the mental models and thinking tools really matter. And so you can illustrate the kids' thinking using a number line. So a lot of the thing with the number talks is recording faithfully as kids describe to you. So if somebody said, I see it as 15 plus 1, you would draw an open number line, show a jump to 15, show another jump up 15, and show another little jump of 1 more, and that's how you would illustrate it. So definitely don't discount the thinking tools. So we haven't seen the number line in tonight's session, but again, one of the simple things that we really totally take for granted. This one, what would kids do? And I think the best, given that we're near the end of this webinar, is that if you can just put in the chat box. But I picked 3 different problems. And now we're getting to the point where kids can add and subtract. We're working on interesting problems with them about adding and subtracting. And we want to see how they know what they know. I'm just double checking my notes here as we get to the end. Yeah, so I have an interesting tweet that came from the ministry session just yesterday. I'll drop that link in. It's just a tweet. You can look at it. But it has to do with how a lot of the story problems for adding and subtracting are either joining or separating groups. And that, if that's the problem frame, and we really know that, we can really know what to look for. Okay. If you have this book, I don't think I've fully articulated that if you have the book, you have the codes for all the videos. So I just picked 3 things. So you would see what kids are actually doing through the videos. So we think kids might use counters to subtract, subtraction by removal. Actually, the teddy bear manipulatives I have would work here. You know why? Because if you give actual gummy bears, they would eat them. You could make them wait till the end, though. But that's a sure way to make that's a subtraction problem, right down to 0. Join 10 frames, so we could go, we could go a 10 and a 5, and then a 5 and a 3. Good, yeah, no, I love the anticipation, and I'm going to highlight that word because it's so important. Anticipate what kids would do. If we're going to give them a problem, anticipate. And again, I want to point to this 15 plus 8 one in particular. If it was a long time ago, we might just say, check, nah, or X, nah, if they got or didn't get 23. But if we can see their thinking, and if we make it visible, our job is a lot easier. So that's noticing and naming what they actually do. And counting up from 5. So regarding the first one, so Lawson is really, really good on counting 3 times and counting all. So when kids are early on with adding, they will need to literally count 3 times to check. Let's see, does one of these problems fit that? I think so. The first one's subtraction, though. So if we think backwards, 5 plus 9 is 14. They would need to count 5, count 9, and then count 14. But counting on would be picking the 9 or the 5 and counting on. And like a more savvy adder might know that through commutative property, 5 plus 9 is the same as 9 plus 5. So they may just pick 9 to start with. But even that, again, pretty sophisticated, right? And if we know they're thinking that, we know they're starting to have commutativity in place. And that's a great thing. School-wide common subtraction task. And most students chose to show an algorithm. Thank you for that. Kids will, if they know the algorithm, that's what they'll want to do first. And in which case, which is fine, and they'll probably got the correct answer, but we have to push them to show their thinking, and convince parents that we actually want to see their thinking, and that it's not just about the right answer. So I wouldn't take the algorithm tool away, but we want to show in the case of adding that because of place value, it works. So we regroup the columns when we get 10, and then we go to the next column. If we don't want blind application of algorithms ever, okay, and I'm going to drop one in the chat box that kids might try and use. Let's see, here, 2001, subtract 1,995 equals. So a lot of times you'll see examples like this. They say, why on earth would you go through all that regrouping when, again, if you flip and I say, 1995, even if you just count on, you get 6, right? So, but you will actually see kids and adults pull out the algorithm just for that. But in which case, a machine, like a calculator or a computer could do that, but we're better at saying, well, we're better at reasoning out the solution. Yeah, and making thinking visible in math classrooms, is absolutely massive. Absolutely massive. And so we need to push kids to do it. So verbally and on paper and just with their thinking tools or manipulatives, which, by the way, it's so easy to photograph and use Google Drive or whatever your board uses. Seesaw or whatever you use. It's so easy to document what kids are doing these days. And it's what they've said, what they've done on paper, and with the thinking tools. If a kid just scribbled something out with number lines to answer one of these questions, I'd want to record that. If they use counters, record it with a photograph. If they talk to you, record them talking or write it down. Why not? That's really good assessment. Just as we reach the end, if there's any questions you want, feel free to drop them in the chat box. In the last couple minutes before we exit, I wanted to give a bit of the bridge to Kyle's presentation. And you can think about if you want to be in it. But I would say, so think of the Fosno addition and subtraction landscape. And if you Googled her multiplication and division, you would see where that starts, just as an example. If your school has the Lawson book and you flip through it, see how kids get in their operational sense from adding and subtracting to multiplying and dividing. But we've had some massive clues tonight having to do with seeing units, skip counting. Okay, so starting to see that the unit doesn't have to be 1. Skip counting, making tens. So we're starting to see how kids would eventually make that bridge to multiplication. So even with my 6-year-old, he's never heard the word multiplication, but I can start to show him when we do counting things, start him to arrange equal groupings, and he's starting to see these efficiencies, as I've said, counting by 2. So I really do think that that's the bridge. But so moving from additive thinking generally to multiplicative thinking generally as you go up through the grades in math is massive. So in patterning and algebra as a subject, that's a lot of times where you see it. When kids don't make this jump, and we also see it on a day-to-day basis. So-and-so doesn't know their times tables, right? Which, yeah, in a lot of cases they don't. But in a lot of cases mean they haven't been exposed to this progression, as Kyle calls it, of multiplication. So I'm strongly encouraging you to be here next week. And I'm going to leave you right at the doorstep of multiplying. And I think that's about where I'd like to leave you tonight. If you want to impress some kids, that simple number trick where we disguised it, we said think of a number, double it, multiply your number by 5, do a bit of magic, tell kids their number. Make math playful pedagogy of mathematics. Let your kids surprise you with the power of their thinking, and let your classrooms be places of surprise and wonder always. And unless there's any final thoughts, I'll just answer any questions if they come. And I thank you very, very much for coming. The participation tonight was really, really great, so thank you very much. And look up that recording later, take the Subitizing images, whatever you need to do, and I thank you very, very much. It was terrific. Okay.
Thank you so much, Matthew. Well, you know, we are finishing a few minutes early, which is not bad. 3 minutes early. It's a little bit like at the end of the math teachers at the end of the math lesson when the teacher tells the class that they can go on a break early. I don't think that you often hear complaints about it. Except perhaps when it's a fun class with math as the teacher, of course. If you guys have been in some OTF Connect sessions before, you certainly can appreciate that Matt is truly a unique facilitator. Other presentations tend to be far more structured, and this is not a criticism. To the contrary, formal presentations also tend to be sometimes more boring, which is definitely not the case with Matt. I love the way he works with us throughout the evening. And obviously, I must say that Matt, you would have been a great actor in the League of Improv, something you may want to think about. Anyway, thanks so much for this excellent and interactive and really fun presentation. And as always, I also want to thank all of you for being such fantastic participants and motivated teachers, and for sharing your ideas and your pictures along this session. So a special thank to Jennifer and Cindy, Eniko, Kristen, and Kathy, who sent me emails, and then some of you who shared with Google Drive. I think that cool teachers tend to bring out an element of coolness in their classes. I mean, I don't know if really there's such a word as coolness, but I think that you all know what I mean. And this was certainly a fun and interactive session. So just a couple more slides, 4 to be exact, which is 2 plus 2 if my math is correct, or 5 minus 1 or something like that. So the list of upcoming sessions we have on March 29, the Power of Materials in Learning with Tessa Efferman. She's a brand new facilitator for OTF Connects, and I really look forward to working with her on this presentation. So if you want to participate to support her, she would love it, I'm certain. Then on the following day, on March 30, as Matthew indicated, we have a presentation by Carl Pierce, also on multiplications, and Carl is one of my favorite facilitators. Matt and Carl often work together, and if you enjoyed Matt's presentation tonight, you will certainly love that one as well, so I warmly encourage you. And then on April 20, that's almost a month later, we have Laura Ginny Newman, and she will be back for the second part of her presentation on, I think it's kind of critical thinking in the math classroom. The date for this presentation has been changed, so it's actually on April 20 for part 2, not to be missed, particularly if you enjoyed part 1 of that presentation a few months ago. There are still places available for this session, so don't hesitate to go on our calendar. I'm actually going to paste the link to our calendar page and to register for these sessions. I also would like to tell you about an opportunity provided by OTF and the Ministry of Education. If you are a qualified teacher and completed an additional qualification course in math, technology or kindergarten, you may be eligible for a $450 subsidy. So I'm going to give you the link to that page if you want to apply for it. Then as you are going to exit Blackboard, you will be given an opportunity to provide us your feedback, and that is very important to us. The survey only takes a few minutes, so if you could do it right after the session, it would be greatly appreciated. You will be redirected automatically when quitting Blackboard. As a new feature of our webinar, you will also be given an opportunity to enter your name to receive a certificate of participation to this training session that you will be able to then add to your professional resume. If you don't have the time to do any of this tonight, don't worry, because we will send you a link, all the links tomorrow, and I will also paste them right now in the chat box. And I also would like to provide you with the link to the resource page of Matthew's presentation tonight. It will be live later tonight, but for sure tomorrow morning. So that's the link to Matthew's presentation tonight. So that's it. We had a great time tonight. I just want to conclude this presentation and invite you to follow OTF on social media as well as on our OTF website. Thank you once again for your participation in tonight's session. We certainly hope to see you soon on OTF Connects. Bonne fin de soirée à tous et à toutes, et encore merci de votre participation. Nous espérons vous retrouver très bientôt sur OTF Connects. Merci.